Hello, and welcome to Chapter 2. Let's take a look at a couple of sections with some of the set theory problems and notation to help you as you work on your homework. We're going to begin with Section 2.3 and Venn diagrams and set operations. You'll notice that there are quite a few different objectives for this section, so we're going to do some review of the symbolism as well as problem solving. First of all, the universal set is a general set that contains all the elements that we're talking about. You'll notice the little U up here, and that indicates whatever the elements are that we're dealing with would all be contained in this rectangle. Set A is then denoted as the circle, and the things outside circle, or what we call a complement, are denoted as the A with the little apostrophe. So if we wanted to talk about the universe in this particular problem, the universe would include the square, the triangle, the $sign, the capital M, and the phi. Set A would only include the square and the triangle. The set of elements in U that are not in A, or what we call a complement, would be the $sign, M, and phi. Disjoint sets are two sets that have no elements in common. You notice that there's nothing overlapping between A and B. Proper subsets are where all the elements of set A are also elements of set B. But then you would notice that B might still have some other things in it. If A and B are exactly the same, of course, then it can just be one circle because we're talking about the same items. If A and B have something in common, but not everything in common, which is usually the case, then they're going to overlap, and so the dark blue shaded area are the area or the elements that are in common between A and B. In this particular Venn diagram, the universe is A, B, C, D, E, F, and G, or we might just easily call it regions 1, 2, 3, and 4. Set B contains D and E, or regions 2 and 3. Set C, the set of elements in A but not in B, would only be A, B, and C. It cannot include D because that's also in set B. Set of elements in U that are not in B, A, B, C, F, and G. Think about it. Here's set B. And if in your mind's eye you kind of cut that circle out or cover it up, what is left? A, B, C, and F, and G. Don't forget the ones out here in the box. Sometimes students forget those. Set of elements in both A and B would be only D. Now, we alluded to this before. The complement, denoted as the A with the apostrophe, are all the things outside set A, but still inside the universe. So here, the complement is 2, 5, 6, 8, and 9. The intersection, which is written as A upside down U, B, is a set of elements common to both A and B. So for example, if we're looking at 7, 8, 9, 10, 11, and 6, 8, 10, 12, we would say, well, the only thing that they have in common is 8 and 10. 1, 3, 5, 7, 9, and 2, 4, 6, 8, well, they don't have anything in common. So their intersection is the empty set. What if you had the empty set and you're looking for where that overlaps with 1, 3, 5, 7, 9? Again, nothing. They have nothing in common. Union, written A-U-B, is a set of elements that are in A or B or both. So this is kind of putting everything all together. So 7, 8, 9, 10, 11 plus 6, 8, 10, 12 is going to be 6, 7, 8, 9, 10, 11, 12. 1, 3, 5, 7, 9 union with 2, 4, 6, 8 is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 3, 5, 7, 9 combined with the empty set is just 1, 3, 5, 7, 9. A little side note then, if you think about this, it does make sense. What does set A intersect with or overlap with an empty set? Nothing. They have nothing in common. There's nothing that could overlap. On the other hand, if I have set A and I add the empty set, meaning I'm not adding anything, I still just have set A. Now, if we have more than one set, and we're going to be doing some operations, this is just kind of like the order of operations with everyday numbers. So we can say find A union B and then find the complement, kind of like you do what's inside the parentheses first. So A union B will be 1, 3, 7, 8, 9, 10. And the complement would be what's left, 2, 4, 5, and 6. Find A complement intersect B complement. A complement, in other words, what's left if we took out 1, 3, 7, and 9, would be 2, 4, 5, 6, 8, and 10. B complement, if we went back to the universe and took out 3, 7, 8, and 10, we'd only have 1, 2, 4, 5, 6, and 9. And then our third step is to see where they overlap. So let's look at these. Where do they overlap? 2, 4, 5, and 6. Now this one we're looking at a Venn diagram, and we're determining what parts of the diagram answer my question, like what are the members or elements. Again, we're talking about region 1, the part of A that doesn't overlap with B, region 2 where they overlap, region 3 that's just B, and region 4, of course, is everything outside it. A union B, all of A plus all of B, pi, E, square root of 2, square root of negative 1, e to the pi I, 10 to the 100, and 2 to the aleph nun. Regions 1, 2, and 3. A union B complement. This is all of A and B, everything inside those circles. So the complement would be everything outside the circles. So that's 666, or region 4. A intersect B. Where do they overlap? Region 2. Square root of 2, square root of negative 1. Which, by the way, for those of you that have had higher mathematics, is I, or what we call a complex number. A intersect B complement, letter D. Well, A intersect B complement is this little piece here where they overlap, so the complement would be everything outside it. So it's pi, E, e to the pi I, 10 to the 100, 2 to the aleph null, 666, or regions 1, 3, and 4. And if you take a look here, they kind of summarize this for us on the slide, all the regions, or the set and roster form. Or means union, and means intersection. So back to that idea of cardinal numbers, how many things are in my set? If I want to find the cardinal number of the union, I'm going to say how many things are in A, how many things are in B, but I want to make sure to subtract off anything that got counted twice. For example, suppose we had a blood drive on campus and 490 students were willing to donate blood, 340 were willing to kind of help set up, clean up, and provide breakfast, and 120 students were willing to do both. So the question would be how many students are willing to donate blood or serve breakfast. Now remember, or means to add. So we're going to have 490 plus 340. We're going to have to subtract off the students that were willing to do both. 490 plus 340 minus 120, 710. Next section, Venn diagrams. Continue, but now with 3 sets. So this one says A, B, and C. Find A overlap with B union C complement. Remember, we do what's inside the parentheses first. So C complement, 2, 3, 4, 6, 7. The complement would be 1, 5, 8, and 9. And then I'm going to put that together with B. So I'd have 1, 2, 3, 5, 8, and 9. Or 1, 2, 3, 5, 6, 8, and 9. And then I want to find where does that overlap with A. So the first thing we're going to do is find the complement of C, 1, 5, 8, 9. Then your union of B and C complement, which was 1, 2, 3, 5, 6, 8, 9, as I said. And then where do they overlap? Look carefully at these 2 sets. What do they have in common? 1, 2, 3, and 5. Now, if you look at it in a picture form, sometimes it's easier. So where do A, B, and C overlap in this picture? Well, A, B, and C all overlap in the darker shaded blue region, or region 5. Region 6 is where B and C overlap, but it does not include A. Region 1, for example, is A only, but does not include B or C. So you can kind of read over these and learn a little bit more about which regions represent what parts and the notation that would go along with it. What's in region A? Set A, all the elements in A would be regions 1, 2, 4, and 5, and it would include 11, 3, 12, 5, 6, and 7. And typically you would enter those in order, so you'd have 3, 5, 6, 7, 11, and 12. How about B intersects C? B intersects C is sections 5 and 6, or if we listed the roster elements 5, 7, and 9. Take some time to work through the rest of these too, thinking about what each of the symbols means and working through them carefully. You can actually prove that two sets are equal using this kind of a method. If both sets here, A intersect B complement, and A complement union B complement, end up being the same regions, then they are equal. Set A is regions 1 and 2. Set B is regions 2 and 3. A intersect B is region 2. The complement of that would be 1, 3, and 4. Now we're going to do the other one. A complement union B complement. A complement, everything outside circle A would be 3 and 4. B complement, everything outside B would be 1 and 4. So what's the union of that? 1, 3, and 4. Well, that's what we got before, which means they are the same. And they prove something called De Morgan's law. Now, if you want to sound very mathematical, you can say this. The complementation of the intersection of two sets is equal to the union of the complements of those sets. Or the complement of the union of two sets is equal to the intersection of the complements of those sets. But it almost starts to look something like kind of the distributing of a power, if you will. Take a look here. If we ask for the complement, that's going to be A complement, B complement. But we flip the symbol. It goes from intersection to union. So if we have the complement of the intersection, it becomes the union of the complements, and vice versa. Our next section is where we start to actually use this stuff to answer questions. And this is where Venn diagrams do get used for surveys. Let's go back to the one about students donating blood or serving breakfast. How many students are willing to donate blood? Well, that was set A. How many students were willing to serve breakfast? We call that set B. How many were willing to donate blood but not serve breakfast? And so forth. So we put our students in the picture here. We had 370 who are willing to serve breakfast or donate blood, excuse me. We had 220 willing to serve breakfast, and we had 120 that were willing to do both. And so we've labeled those accordingly. And then, of course, there's 290 out here that were not willing to do that. And we could ask the question, how many students are willing to donate blood? Well, that would be circle A. All of circle A. So it's 490. How many are willing to donate blood but not serve breakfast? Well, that's the 370. That's the part that does not overlap with circle B. How many weren't willing to do either? Well, that's the 290 that were outside circle A or B. So how do we go about doing these kinds of problems? Obviously, that one was set up for us. But first, we're going to draw a Venn diagram. And then we're going to use the survey results to try to work our way out from the inside out on that Venn diagram with cardinality, finding how many are in each set. And then once we finish our Venn diagram, we can answer questions about it. So here's an example. It says we asked 2,000 randomly selected U.S. and Mexican adults, do you agree or disagree that the primary cause of poverty is societal injustice? So 1,060 people agreed, and 400 Americans agreed. Then it tells us that half the adults surveyed were Americans, so that means 1,000 and 1,000, 1,000 Mexican, 1,000 American. And it asks us how many agreed, if they were Mexican, and how many Mexicans disagreed. So first we're going to draw and label. So the sets we're dealing with here is the set of Americans, and then we have a set of agreed. And then the people outside the U.S. circle would be Mexicans, and of course if they fell in here they'd be agreeing, and if they fell outside the whole circle they'd be disagreeing. So we're going to start in the center, and we find out that we had 400 people who were American who agreed. So that goes into where they overlap. Now we know that there were 1,000 total Americans who participated in that survey, which means that the rest of the American circle is 1,000 minus 400, or 600. Now, we do know that on the other side, set A, or the set of people that agreed, was 1,060. Well, wait, we already knew that there were 400 in the center, so we should be able to do some subtracting. 1,000 minus 400, or 1,060 minus 400. Oh, that's where our 660 comes from. See what we're doing? Giving you some time here to think about that as we're walking through the problem. Now, how do I find out how many people were left out here? Well, now wait, let me go back and think. We surveyed 2,000 people. 600 plus 400 is 1,000. Plus another 660 would be 1,660. Subtract that from 2,000, and we have 340 remaining. Okay, so that 340, let's talk about that. They're not inside the U.S. circle, and they're not inside the agree circle, which means they're Mexicans, and they disagree. So now we're able to answer our question. 660 agreed that it was the primary cause, and 340 disagreed. And here's another one. This one has 3 categories. So we asked 60 people about movies, and we wanted to find out, do you like comedies, do you like drama, do you like science fiction? And so here's the results of our survey. We have 6 people that liked all 3, 13 liked comedies and drama, 10 liked comedy and science fiction, 11 liked drama and science fiction, so on. You read all through that and you go, I can't make sense out of it. Well, we can. We're going to use a Venn diagram. So, and it's helpful here if you printed these out already as you're following along with this, but we start in a center. You always start where they overlap. So 6 people liked comedies, dramas, and science fiction. So I'm going to put 6 right here in the center. Now we knew that 13 total liked comedies and drama. 13 in total liking comedies and drama meant that where we overlap these 2 circles needs to add up to 13. But wait a minute. Sorry about that. That 13 means that if I've already accounted for 6, there must be 7 left here. Okay. I'm going to do that again. Let me see. Well, now, how many liked drama and science fiction? Well, that was 11, which means 11 minus 6, this piece is going to become 5. Well, how many liked comedies and science fiction? Well, that was 10. That means this little piece to the left is going to be 4. That's what we're filling in over here. Now you filled in your little kind of flower petals here on the inside. Now we want to know the big circles. Now we know the total number of people that like comedies was 26. So far we have 7, 6, and 4. That adds up to 17. So 26 minus 17. We're going to know that there are 9 who only liked comedies. They don't like dramas because it doesn't overlap with that. And they don't like science fiction. It doesn't overlap with that. How about drama? Let's see. We have 7, 6, and 5. That adds up to 16. Nope, I'm sorry, 18, excuse me. And the total here is 21. So 21 minus 18 is 3. How about science fiction? 4 and 6 is 10, and 5 is 15. We know the total circle has to be 25, which means there must have been 10 who said, I only like science fiction. I don't like comedies and dramas. So now we've filled in our circle, except for the fact that you do know that we surveyed 60 people, and we haven't accounted for all 60 people in here. 9 and 7 is 16, and 3 is 19, and 5 is 24, 30, 34, 44, which means there are still 16, 60 minus 44, there are still 16 people out here, which means those 16 people do not like comedies, dramas, or science fiction. They don't like any of that. Maybe they only watch other types of genres. They don't like those movie styles. Now we can go through and answer our questions. So how many liked comedies, but neither drama nor science fiction? Well, that's the 9. How many like dramas and science fiction, but not comedies? Okay, so that means dramas and science fiction, but not comedies. So no comedy are included. How many are we looking at there? Well, right here, 5. Because you can't include these 6 because they also like comedies. So we're only looking for where these 2 overlap. Dramas, or science fiction, but not comedy. Remember, or means to add. So we're going to kind of look at all of this, 3, 5, and 10. Again, not intersecting with the comedy circle, or 18. How many liked only one movie style? Well, let's see. The movie style here, these 9 only liked comedies. These 3, region 3, only liked drama. And these 10, region 7, only liked science fiction. So 9, 3, and 10, or 22. How many liked at least 2 movie styles? That would be 7, 4, 6, and 5. Because the 7, 4, and 5, they like 2, and the 6, they like all 3. That's, again, 22. How many didn't like any of them? We already figured that out. Those are those 16 people in region 8. I hope that was helpful. Remember, practice makes perfect. Be sure to check other videos on YouTube if you found this helpful. And practice, practice, practice. Use your study plan. Good luck.